Multimodal biometric systems or multi-biometric are those that utilize more than one physiological or behavioral characteristics for enrollment, verification or identification. What is the motivation for the multimodal biometric authentication? Following are the reasons for moving to multimodal biometrics. First of all, to permit choice of biometric modality for authentication. Second, to increase the population coverage by reducing the failure to enroll rate. Third one, to enhance the performance. Fourth one, to extend the range of environmental conditions under which authentication can be performed. Fifth one, of course, to improve the resilience to spoofing. Therefore, multi-biometrics can further be classified into 4 types because it's very vast. Therefore, it is classified under 4 categories. The first one is multimodal biometric system. The second one is multi-algorithmic biometric system. Third one, multi-instance biometric system. And the fourth one is multi-sensorial biometric system. Multimodal biometric system. Multimodal biometric system fetches the input from single or multiple sensors measuring 2 or more different modalities of biometric characteristics. For example, a system combining the face and iris characteristics can be considered for biometric recognition, and this is called as multimodal regardless of whether face and iris images were captured by the same devices or different devices. It is not required that the various measures can be mathematically combined in any way. For consideration, a system with fingerprint and face recognition could be considered multimodal, or if R rules can also be applied, allowing the users to be verified for the modalities. The second one is multi-algorithmic biometric system. Here, the multi-algorithmic biometric systems take a single sample from a single sensor and process that sample with 2 or more different algorithms. The technique could be applied to any modality. Algorithms can be designed to optimize the performance under different circumstances also. The third category is multi-instance biometric systems. Multi-instance biometric systems use one sensor or possibly sometimes multiple sensors to capture samples of 2 or more different instances of the same biometric characteristic. For example, systems fetching the images from multiple fingers are considered to be multi-instance, rather multimodal. We do it in a typical example is your Aadhaar enrollment. Moreover, systems capturing, for example, sequential frames of facial or iris images are considered to be multi-presentation rather than multi-instance. This is whether or not the repeated captured images are combined at the image or the feature level or some other level of combination, or a single image is selected as the one best used for pattern matching. The fourth type is the multi-sensorial biometric systems. Multi-sensorial biometric systems sample the same instance of the biometric trait with 2 or more distinctly different sensors. Processing of the multiple example samples can be done with one algorithm or some combination of multiple algorithms. For example, in the field of face recognition, both a visible light camera and an infrared camera coupled with specific frequency or several frequencies of infrared illumination. For a particular application in an operational environment, there are numerous system design considerations such as improved performance. For example, the verification or identification accuracy, the system speed and throughput, robustness and resource requirements, acceptability, circumvention, ease of use, operational cost, environmental flexibility, and population flexibility. These are some of the factors that decide on that. Especially for a large-scale identification systems, there are additional system design considerations such as operation and maintenance, reliability, system acquisition cost, the life cycle cost, and planned system response to identified susceptible means of attacks, all of which will affect the overall deployment of the system. There are certain striking advantages of multimodal biometric systems when compared to unimodal biometric systems. Systems are resistant to intra-class similarity of data like facial feature. They combine more than one modality, enabling reduced intra-class similarity. Second one is noise resistance. Multimodal systems are more resistant to noise compared to unimodal biometric systems as they have more than one modality and more data is available for matching. Finally, they are less vulnerable to spoofing as it is difficult to spoof more than one modality simultaneously. Therefore, multi-factor authentication, multimodal biometrics, they are the promising technologies that can handle some of the upcoming attacks. So the reason one is also called the fusion. So fusion in multimodal biometrics is another promising area. In recent decades, multimodal biometrics fusion techniques, they have attained much focus of interest as additional information among the diverse modalities could enhance the performance of the entire authentication process. Most of the works have concentrated on multimodal biometrics only. A multimodal biometric system requires an integration scheme to fuse the information obtained from various individual modalities. Further, it is broadly classified into three major levels like fusion at the feature level, fusion at the match level, and fusion at the decision level. Let us not go into the details of all these. However, I can say that a combination of technologies will definitely provide a secure system. So to conclude, in this section, biometric based authentication methods are discussed. They are gaining importance due to their robustness and strong authentication mechanisms. We clearly discuss about the various authentication methods, their advantages and limitations, applications, and the entire authentication process. So thank you very much, students, for your very patient listening, and we'll continue in the next class with much more details on another section of cyber security.